on page 30. Note, we're up to question C. C. Have a right angle here. Alright, so before we address the question, what type of quadrilateral do I have drawn there?
Parallelogram.
Okay, specifically a rectangle because of the right angle there. Okay? So yes, a rectangle is a type of parallelogram, but a parallelogram is not a rectangle necessarily. Okay? The only way it is a rectangle is if there is a right angle. Or all four. You only need to be shown one right angle for it to be a rectangle because all the sides are parallel, and then using of course our co-interior angle properties we'll be able to justify all the angles are 90 degrees. Alright, so we have AC is 5x take away 1 and BD is equal to 2x plus 17. Alright, so the question asks you to find the length of each diagonal. Alright, so you're told an expression for both the diagonals, okay, AC and BD. Alright, so we need to find the actual length of the diagonal, okay? So how am I going to do that? Well, we don't actually know how long and wide the rectangle is.
Well, they're both equal.
Yes. Alright, so the diagonals of a rectangle are equal. Okay, the diagonals of a parallelogram are not equal. Alright, because when it gets slanted over, there will be one diagonal longer than the other. They do bisect each other, but they're not equal. Okay, so in a rectangle, the diagonals are equal. Alright, so therefore the diagonal AC must equal the diagonal BD. So in other words, 5x take away 1 is equal to 2x plus 17. And look at that, we have an application of equation. Alright, three-step equations, we've done this. So we first remove the variable from the right to the left by doing the same thing to both sides. So there's no variables on the right hand side, so we move any constant terms from the left over to the right. And then we get x by itself. Alright. So the question asks you specifically find the length of each diagonal, so you are not done there. This will probably be a 2, maybe 3 mark question. Okay, if you stop there, you will not get your full marks, okay, because it asks you specifically the length. Alright, so you need to say AC is 5 lots of 6, take away 1, so which is 29, and it should be, of course, the same as the length of BD. So BD is also 29 centimetres. Alright, so you should be checking, so 2 times 6, which is 12, plus 17, yes, we've got 29. Okay, so that's your way of checking the solution. Okay, by using strategies that we have learnt in equations to justify a solution, whether you are definitely not incorrect. Right, D. Squeak. That's better. That's better. 1, 0, A, B, C, D, and we know that is equal to that. Alright, so what type of quadrilateral do I have there?
Regular. If they're equal, those sides. Rhombus. It's that one.
Is that what you're going to say?
Yeah, because they're.
Okay, so yes, it is a parallelogram because both opposite pairs of sides are parallel, so it is a parallelogram. Okay, but because also in a parallelogram opposite sides are equal and parallel, that's a property for parallelogram, and because these adjacent sides are equal, okay, mean these two other sides here and here will also be equal because of the opposite side property, and we have specifically a rhombus. Okay? Now, the other property with the rhombus and a square. So unlike a rectangle, where the sides are not equal, the adjacent sides are not equal, when you have adjacent sides equal, so a square or a rhombus, the diagonals bisect each other, so that will equal that, that will equal that, but they will bisect each other at 90 degrees, okay? Square or rhombus. Diagonals bisect at 90 degrees. Alright, and this is all in that section of the notes that you will need to read over, and I'm covering it when the questions come up. Okay, and it's all included in there. Right, so the question, find angle BAO and angle ABO. So BAO, so we need this one, and ABO, we need that one, called X and Y. Alright, so we're told down the bottom here is 51 degrees. So how I'm going to find one of the angles. Now, because it asks you to do BAO first, probably meaning that that one will be the more straightforward to get one first. So angle BAO equals what and why? Because alternate angles, alright? So parallel line, transversal, there's your Z, that angle equals that angle. So angle BAO is equal to 51 degrees. Alternate angles on parallel line are equal. Back here, AC equals BD, diagonals are equal in a rectangle. Okay, so I'm going to go back and pick that up please from the previous question. Right, angle ABO equals what?
180 take away 90 take away 51.
Good, okay, so we've identified the right angle here already. That means every single angle in the centre is a right angle because of vertical, opposite and supplementary properties. Okay, so we have a right angle here, we know the value for that one up here, therefore by the angle sum of the triangle, so 180, take away 90, take away 51. So 90 take away 51, so 51 plus 9 is 60, and then another 30 gets to 90, so 39 degrees. Right, and the reason, angle sum of triangle is supplementary. Is that squeaking annoying anyone? No? Get my notes a little bit. Look at them right there. Okay, any questions so far? Okay, everyone's following what's going on? Right, let's try E. Alright, so extension students, I've already talked to you about this morning, the rest of you students listening. When you read a question, okay, while you're reading the question, you are making sure that information is on the diagram, okay? Just because it's in the question itself doesn't mean it's in the diagram, and just because it's in the diagram doesn't mean it will make reference to it in the question, okay? So as you are reading, so I'll put what's already there. Alright, so D and E are the midpoints respectively of sides AB, AC of a triangle. Alright, so that's there. DE is produced to F so that DE is equal to EF. That's there on the diagram. We need to show that BDFC is a parallelogram. Right, so what are the properties of a parallelogram? What's the main property? Opposite sides are parallel. Okay? Right, how are we going to do it? How are we going to successfully show that the opposite sides there are parallel? What could we do? DAE equals okay, so the big picture is we need to show some angles property and then hopefully show either relation to alternate, corresponding or co-interior that we can have some parallel sides. Okay, so first thing we need to do is in triangle ADE in triangle ABC. So in order to show some relation to some of the angles, we need to show first some similarity or congruence. So the two triangles are obviously not congruent, with one is longer than the other. Okay, so we will show similarity. So we had 3 tests to show for similarity when we did this last lesson on Tuesday.
You can prove that triangle AD is congruent to triangle EFC, therefore making that with EFC similar, parallel to EB.
Good. Yep. Yep. Good.
Right.
So I think we have to do 2 things because. Okay, so what Mikhail was saying is that triangle is going to be congruent to that triangle. Yeah, that's why we do it actually. Well done, you picked a quicker way to do it than I was doing it there. Yeah, we can do that. That might be enough. Alright, let's have a go. So, what Mikhail is saying is if we prove these 2 triangles are congruent, we'll be able to get some of these angles here and hopefully relating to some of the other angles in the diagram. So, in triangle ADE and the triangle EFC. Okay, so I'm going to stop here because we just discovered another way we can approach the question. Now there is more than one way to do it. There is no one set way. Okay, so obviously I had a method. Now my college picked up something that might make the working a bit quicker. Alright. So the property of that top triangle, let's go AE is equal to EC, given. Okay, because they both have double marking. Right, so we've got DE and EF. Which is also given. And what's the final property I need? Vertically opposite angles. Alright, so angle AED is equal to angle FEC. Therefore triangle ADE is congruent to triangle EFC, side, angle, side. Okay, because the angle was the included angle between them. Alright, so if you rotate that top triangle about the point E, alright, so if you rotate this top triangle about the point E here and you bring it around, alright, that point A will be on the bottom of point C there. Okay? That means these 2 angles are equal because as you rotate them, that'll be there. Alright? And that will also mean the angle formed ADE will be the same angle at EFC. Okay, they're the matching angles. Alright, so if I label it here, let's label X. Okay, could we just shown that? Alright, so might say this is equal to X here in part of my proof. Okay, and therefore that implies the angle, so as you rotate this down, the angle ADE, let's call it Y, is equal to angle EFC. Okay, as you rotate it down and around, that's where it'll sit on top of each other. Okay, the reason. Matching angle in congruent triangle.
Does that mean AD is FC as well?
That again?
After you've proved that it's congruent, doesn't AD equal FC? Yep.
Yep, so all the matching sides and the angles are all equal. Right, what's an expression for angle BDE? What's this angle here in relation to what's already on the diagram?
180.
So angle BDE, the 180 take away y. Alright, angles on straight line, supplementary. Okay, and the whole reason of having diagrams is so you can include all that information on there. So what can you tell me now with the information on the diagram relating to what we're trying to get overall?
Angle FCB equals
FCB and FQB are supplementary. Oh wow.
could just be one triangle.
Oh wow.
I was just like a triangle,
So just silly. DBC equals 180 take away. Wait, is that a Y at the top? Yeah, it is. Take away.
Because?
Seems like a god.
Doesn't have to be. Parallelogram.
But this is a mathematics class, not extension. Alright, let's go this first. Angle B, so therefore angle B DE plus angle EFC is 180. So this angle here
Yep.
plus that angle there, 180. That plus that, the y's will cancel and you're left with 180. Okay, which is a supplementary result, which implies that BD is parallel to CF because co-interior angles on parallel line are supplementary. Alright, so we've successfully shown this is parallel to here. And now we need to show the other two opposite sides are parallel. Or we could have done alternate angles. We could have done this. So the Z shape here. Yeah? Okay, so that's another statement you could have made in terms of parallel. Right, so I need to show that DF is parallel to BC. And this is where I was starting my question because I could have done it with my start. So you're probably going to have to do what I'm about to do. Unless then I can see a quicker way to show DF is parallel to BC. Alright, so back to my start. Triangle ADE and triangle ABC. Yep, from where I started. Because I was going to show that was equal to that, and then we would have had our corresponding angles. Okay, so unless we can see a quicker way of doing it, we're going to have to do it like this. Right, so that little triangle at the top and the big triangle formed at the bottom. Okay, so we have an angle at A is common. The ratio of the side in the smaller triangle over the side of the bigger triangle, so be AB. So if AD was caught 1 unit long, therefore AB must be how long? 2 units long, because equal marking. So if we call this 1 unit long here, this must be the same distance, so you add them both together, you're going to get double the length for the big triangle. And the other side, so AE over EC will also be in the same ratio because of the equal marking. Okay, that length, if we say it's 1 unit long, again, this is double the length when you add them together. Okay, because they're both the same distance. So the ratio is going to be 1 over 2. Okay, therefore, triangle ADE and triangle ABC, therefore triangle ADE is similar to triangle ABC. Alright, so we did side, angle, included angle, and the side in the same ratio. Yep.
Should it be AC instead of AC?
Yes, thank you. Just testing you. Alright, so because they're similar, that angle here must match the angle here, and this angle here must also match the angle down here. Wow, we did some circle geometry questions that were much quicker, didn't we? Those people doing mathematics, you're thinking the geometry is hard here, you should come join us for our morning lesson. Alright, so therefore, angle ADE is going to match the bottom one here. Angle ABC, which is Y. Right, the reason matching angles on the similar triangle. Okay, which then implies that my DF must be parallel to BC because you've got the upside down back to front F, sorry, upside down F, and underneath the arms are equal, so they'll be corresponding. You discover a quicker way to do it. DF and BC.
Yeah. But if Y was there ages ago, you could run the assumption that the two Y's are equal, therefore it's corresponding angles on parallel lines.
Where's the other Y?
The Y up there.
EFC.
Yeah.
Did that one just come in?
I did see.
With what one?
When did that come in?
This one?
No,
Yeah,
both.
we just read it then.
Just then.
Yeah, we just did
Okay.
that. Nick. Hey, change your goddamn view.
Oh, it's those shoes, Robin. Right, because corresponding,
No, we did that ages ago.
No, the bottom line.
that one, yes, but I just put that one there.
Okay.
Maybe you should be paying attention. Corresponding angles on parallel lines are equal. So we've just now successfully shown these two sides are parallel. Hurrah. Okay, so now we're showing opposite sides of parallel. That's enough to show a parallelogram. Alright, therefore, B, D, F, C is a parallelogram since opposite sides are equal. Look at that, almost a whole board.
Crazy. Yeah, but didn't like half of it fail?
No.
We needed the start. Now I am about 75% sure there's a quick way. I just hadn't identified it yet. That's the thing, is you can't identify it quickly, you're just going to have to run with what you got until you can successfully prove the property. But in your assessments, you'll be looking for your marks, the mark allocated per question. So if you see this question and it's worth 1 mark, for example, it must be a very quick way to do it. But if this question's worth 3 marks, you'd be thinking, I've got to do a little bit to get those marks, okay? Because there's a bit involved in the question itself. So I'll have another crack at it in my own time and see if there is, in fact, a quick way of doing it. Anyways, any questions about the whole approach? Could that use congruent triangle? That use similar triangle? That use cointerior angle? That used corresponding angles? It used vertical opposite angles? There's almost your whole geometry course covered right there. Almost. So if you've mastered that, you've done geometry very well. Alright, F, in quadrilateral, A, B, C, D. A, B, C, D. Okay, got that, equal to that. We had that, equal to that. And we have right angles in the middle. Okay, so again, reading the question. So in quadrilateral ABCD, AB is equal to CD, yes. DO. DO equals OB, yes. And AC perpendicular to BD. So perpendicular means meet at right angles. We need to show that ABCD is a rhombus. Nice. Alright, so what are the properties of a rhombus? Diagonals bisect each other. What else?
Diagonals cross right angles to each other.
Mm-hmm.
Diagonals bisect each internal angle. Oh, it's actually yeah, I didn't actually know that. Opposite sides are parallel. All sides are the same length. Diagonally opposite internal angles are the same.
A lot for a rhombus, isn't it?
Yeah.
And there's one more for square. Alright, so in a rhombus, we've got a rhombus, let's do a quick one, A, B, C, D. Alright, all sides are equal. Okay. All the opposite sides are parallel. Okay. The diagonals bisect each other at 90 degrees. And the angles where the angles bisect, they are all equal. Okay? in a nutshell.
So AD and BC. Oh, we have to prove that. How do we prove that? Ah.
Yeah, we do. How are we going to do it? And I reckon we'll be continuing on to Monday.
Use the congruent triangles at all.
Sorry?
Use the triangles, the congruent triangles.
Yep. We can make a start with that.
Angles and have sides. Could you prove that DOC is congruent to BOA?
DOC to BOA, yes, we can do that. But you already told they're equal. Oh, sorry, you need to show congruent. Sorry, I get what you're saying. What else can we do? So Kyle's suggesting these two triangles are congruent. Yeah, that'll go a long way to helping us answering the question. Yep. So in triangle doc and triangle AOB. But which of the four congruent tests am I going to use? Not side angle side, nope.
Not side angle.
Well, what angle do we have in there? The right angle, so which test, most likely? RHS, okay, most likely, but not always. So we've got the right angle, we know the length of the hypotenuse opposite those right angles, and we also have another shorter side common. Stop pulling faces, Robin. Alright, so angle DOC is equal to angle AOB. Alright, this was given. DC is equal to AB, also given. And do equals OB. Okay, so nice quick proof there because each of the three properties were given. That's what we like, isn't it? Alright, so therefore, triangle DOC is congruent to triangle AOB. RHS. Alright, so just because this question does not specifically ask show these triangles are congruent, you're still required to do your 5-line proof as if you are showing two triangles are congruent.
Which means
Okay?
AO equals
A?
OC. Does that mean AO equals OC? Yes. Is that proof?
Yes.
Good. Alright, so that means also that implies AO is equal to OC.
Oh, and now you prove that BOC is congruent to AOD using the exact same proof.
Or you could just prove it as long
All that one.
Have you?
Well, it has all the properties, doesn't it?
No, it doesn't make
Does it?
size
Still
of
kite.
That's why you
Still can be a
show that-
kite.
You can use side angle side.
Okay, the difference what we got here, before we can say it's a rhombus, we can still technically have a kite. Alright, because the diagonals bisect at 90 degrees, that equals that equals that. Okay, so these two are still equal, could still be a kite. We need to also show parallel.
A.
Alright,
You prove that they're congruent. No, okay. Yeah. Congruent by
so
side angle
what
side.
Kyle was saying, show the other two triangles are congruent as well.
But you said RHS.
Well, it's not going to be the same proof, so we need to start again. So in triangle AOD and triangle COB. Alright, so we have DO is equal to OB. Okay, given. We also have the right angle at the bottom. Angle DOA is equal to angle COB. Okay, that was given. And we just done with the matching sides of the last pair of congruent triangles that these two sides are also equal. So AO is equal to OC. They don't do anything like this in mathematics, in general, so just saying.
Really? What do they do?
No, they don't.
What do they do?
Currently they're working on taxation tables,
They've been doing it for like,
paying tax,
Oh, yeah.
something that we won't cover.
Cool, 'cause I hate that. Really, I don't like it.
But we will be working out our loan repayment, superannuation, annuities, which is money invested for the future, in your HC course. For those who will be there when it happens. The reason from above in the congruent triangle proof. Okay, so I'm referring to that first one. Okay, so therefore triangle AOD is congruent to triangle COB. Alright, so this one was the angle side test. Is that enough to say it's a rhombus yet?
No.
Nope. But from the test, we can say these two sides are parallel. Are equal, can't we? So 1, 2, 3, 4. 1, 2, 3, 4. Which implies that AD is equal to BC. So matching side of congruent triangles. Okay, so in a rhombus, the diagonals are not equal. So we're not going to go show these two sides are equal. Okay, if it was a square, that's what we do. But in a rhombus, the diagonals are not equal. However, if we could then justify these two sides are equal in length, all right, we'll be done. Because we don't have to show parallel necessarily, we can just do equal sides. However, looking at it again, I'm actually going to go parallel. Okay, so if
Oh, wait.
yeah, so if we go back to my first congruent proof, this triangle, so let's label this X. And when I did the triangle AOB, that means X would have been matching with that one there.
It's ultimate angle thing, so it has to be one.
Yeah, okay, because the Z shape's here. They're alternating. Right, so now I need to show these ones. So if I did angle DAO, if I did that Y, which angle would that be matching in this triangle down here?
ACB.
Where do you get A from?
Oh,
I took the one right.
down there. Okay, and again, you've got your Z shape here. But you need to show your congruent triangles so that you can state those angles were equal. Are we having fun?
Yeah.
Oh, yes.
I love geometry. I love it. I'm good for brains.
Alright, so which implies angle ODC. ODC equals angle ADB. BO and angle DAO is equal to angle OCB. Okay, these were from congruent triangle. From congruent triangle proofs, we had the matching angles. Okay, which implies that DC is parallel to AB, and we also have AD, which is parallel to BC. Hurrah! Alternate angles on parallel line are equal. Alright, so therefore A, B, C, D is a rhombus since opposite sides are parallel. So a square is a type of rhombus is not a type of square. Okay, so since opposite sides are parallel and also the diagonal bisect each other, so that's why we need to show these sides were equal, because they bisect at each other, mean cut in half, bisect each other, and specifically for a square or a rhombus, it is at 90 degrees. Right, and that'll be enough to show, because that what makes it a rhombus, and uniquely a rhombus. Okay, if this was a square, you would have to go further and show that these angles here were all right angles. Okay, the good thing we're stopping at a rhombus.
Where's the logo?
Doesn't matter, it falls.
Well, the wall of this room is really far.
Aren't they all 90?
Yeah, the heat is on.
I'm more awake in here than I was in the room.
Right, so Bell will be going in 4 minutes.
Time to go do some more circle geometry and study in here.
We're going to stop there, because I didn't realise it would take that long. Didn't realise we're proving rhombuses and parallelograms, etc. Right, so that means Monday we're going to finish the course. Finish the course. Finish the
I
course.
wish.
Thank you. Thank you.
This is where paper brands come in.
You had stuff
Oh,
to do.
I need to see you. Now. Why?
Alright, so everything that was finished up the end of last term, that was accessible, except for the stuff covered in the first assessment. So surds, equation, and the geometry that we started, that we finished the end of last term. Okay, so none of the congruent triangles, no similar triangles, and none of this will be in your assessment. Okay, but everything else we did at the end of last term. But that means early term 3, this sort of stuff will be in your assessment then. Okay, in terms of what we've covered with the properties.